Hi guys, this is square root function, the sequel. This is video 2, and so I've already gone through one video, and you notice I've already got a bunch of graffiti on here. But I just kind of wanted to follow this up with the main crux of the matter, which was how do you graph a square root function? So in the previous video, what we did was we kind of explored the square root function as being something in this form, and so it's going to be necessary that we're able to identify three values: our a value, h value, and k value. We recall that k is vertical translation from the original graph of y equals the square root of x, and k tells the truth. Okay, what k says k means, whereas horizontal translation was dictated by h, and we say h was necessarily, it appears to be backwards from what it is necessarily stating. And then the a value is kind of like, but not exactly, not at all actually, slope-ish, but this kind of tells us, it directs us, director, from our original point, which is at 0, 0, to our next point, where if we're looking at this graph over here, we'd say, okay, so 0, 0 went up 1, right 1 to get to this next point, and then we can go and sketch right through it. So real quick, we'll go back over to GeoGebra. I just kind of wanted to see, well, what if we kind of played around with the function? Actually, let's write one down. What if we said, I want to graph f of x. We'll call f of x equals square root of x. Okay, that's our original function. Let's graph g of x, and we say, so g of x is actually 2 radical x plus 1 plus 3. So right off the bat, here's what's going to be essential. We identify that a is 2, okay, that h is actually backwards. It's not a positive one, it's actually a negative one. And then we say k is actually 3. So identifying these things, we say that a is 2, or I'm going to write 2 over 1, that h is negative 1, and k is at positive 3. This kind of tells us how to transform the original graph of the square root of x. Okay, but already before we graph this, what we might indicate is that h being a negative 1 means that our original graph of square root of x is going to shift left 1. We say left 1 unit. This plus 3 out here, which is our vertical translation, indicates it's going to shift up 3 units. Okay, and then our a value being 2 means that it's going to vertically stretch. So sketching this by hand, we would start, honestly, by drawing or considering our original graph that started at 0, 0, went up 1, right 1. Okay, so here's our f of x, which is just square root of x. This new graph, g of x, would be different in that it shifts left 1, up 3, and then is vertically stretched by a factor of 2. So going back to the original here, we say left 1, up 3. Let's start by placing on this vertex point, if you will. We want to go left 1, and up 3. And so we say this new graph would actually start here. So we notice we went left 1 and then up 3 units. And we say, okay, so considering our a value is 2, we could say from this point we will go 2 over 1. We say, okay, so up 2 to 5, and right 1. And we'd land here and we'd say, okay, so now I know these 2 points, I can connect through them to sketch in this function here. So just kind of double checking ourselves in GeoGebra here, we said we had 2 square root, let's write this, g of x equals 2 square root, we had x plus 1 in parentheses, and on the outside we had plus 3, just to see how well we did here. And so you notice that, yeah, we did get a situation in which our vertex shifted left 1 and up 3. Just by looking at h and k values, we were able to determine this. And then also, excuse me, from this new point now, it went up to right 1, okay, to get to our next point, and then it kind of does its thing from then on out. So maybe we look at a different one where we want it to be just like the original graph, but this time let's make a function that satisfies our requirements or our constraints. And maybe our constraints consist of, we want a graph that's like the original, but we want it to shift right 3, up 2, okay, and be a little bit flatter. So let's consider that we want right 3 and up 2. The fact that we want to go right 3, which is horizontal translation, recall that's our h value, and h is a liar, okay? So if we want to go right 3, we're actually going to have to write the square root of, in parentheses, or inside the square root of x minus 3 to go right 3. And if I want to shift it up 2, we'll have to put a plus 2 on the outside of that. And last but not least, we said we wanted to get flatter. So maybe we use like a proper fraction or decimal here. So we say, how about h of x, h of x equals we'll go pretty flat here. How about 0.33 square root, or third there, square root of, we said we want to shift right 3, so we'll go x minus 3 inside the square root. And we wanted to shift up 2, so we'll put plus 2 on the outside. And so here you see, we shifted right 3, up 2. And then as our a value is 0.33, it goes up 0.33 or a third, and then over 1. And then, booyah, Grandma. So, you know, I guess what I'm saying is when you graph square root functions, the only things that should matter to us are a, h, and k. And then using that information, we can just take our original graph of square root of x here and transform it into the graph that we want. So hopefully that helps. Enjoy.